SSLC Chapter 4 Silicon. After studying this chapter, you realize the presence of compounds of silicon in building materials, ornamental stones. Explain the chemical properties of silicon. Describe the extraction of amorphous and crystalline silicon. Differentiate between amorphous and crystalline silicon. List of the uses of the silicon and silicon compounds. Introduction. Even though man was homely with the sand, an important ingredient of the solid crust of this planet, it is surprising that he realized its chemical composition very late. This was because of the reluctance of soil mud to undergo chemical reaction on heating. Sand and quartz compounds of silicon exist in various forms, and this was considered an element for a very long time. Berzelius produced crude silicon from silicon dioxide, that is, sand was identified as silica, and proved that sand is a compound and not an element. Maybe the ignorance of properties, difficulty of isolation, lack of equipment and technique, the silicon was not studied or used for many years even after isolation. Silicon is derived from the Latin word silicium, which means stone or flint. John Berzelius. Earlier, pictures were used as symbols of elements. Berzelius was the first chemist who introduced the representation of elements or their atoms in the terms of letters. This notation of Berzelius helped us to write the structural and molecular formulae of complex molecules. Berzelius, in a mood of frustration, is reported to have said, "Only devil can write chemistry because it grows at a very fast pace." In 1824, John Berzelius first isolated silicon and found it to be an element. General properties of silicon. Symbol Si, atomic number 14, mass number 28, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p2, or neon 3s2, 3p2. Allotropes are amorphous silicon and crystalline silicon. Occurrence. In Earth crust, silicon is the second most abundant element next to oxygen. It is more widely distributed in dust, sand, and planets as various forms of silicon dioxide, that is, silica or silicates. Silicon compound is the chief constituent of semi-precious stones like garnet, zircon, topaz, and opal. Silicon exists in two allotrophic forms. One is amorphous and another one is crystalline. Extraction. Extraction of amorphous silicon. Finely powdered silica, that is sand or quartz, is mixed with magnesium powder and heated in a fire clay crucible. Magnesium oxide and silicon are formed. The product is washed with dilute hydrochloric acid to dissolve magnesium oxide, a basic impurity. Then it is washed with hydrofluoric acid to remove unreacted silica. The powder left behind is silicon in its amorphous form. SiO2 plus 2Mg gives to Si plus 2MgO. Extraction of crystalline silica. Crystalline silicon is obtained by reducing silica with coke. When excess of silica is heated with coke in the electric furnace in the absence of air, dark gray colored silicon is obtained in its crystalline form. Excess of silica must be used, otherwise carborundum is formed, that is silicon carbide. So SiO2 plus 2C gives Si plus 2CO. Comparison of properties of amorphous silicon and crystalline silicon. Amorphous silicon. It is a brown powder. Crystalline silicon. It is a dark gray crystalline solid. It roughly resembles the structure of diamond. Amorphous silicon doesn't conduct electricity at a low temperature. Crystalline silicon slightly conducts electricity. Amorphous silicon is more reactive. Crystalline silicon is less reactive. Amorphous silicon, when heated in the air, it oxidizes at the surface level and it catches the fire. Crystalline silicon doesn't burn in the air even when heated. Though silicon is a non-metal, it is a semiconductor at room temperature. Chemical properties. It burns brilliantly in the air and vigorously in oxygen to form silicon dioxide. Si plus O2 gives rise to SiO2. In this reaction, there is liberation of heat energy. Chemical reactions which liberate heat energy are called exothermic reactions. Silicon is insoluble in water but slowly decomposes with steam. When silicon is in red hot state, liberating hydrogen, Si plus 2H2O gives rise to SiO2 plus 2H2. Recall. When steam is passed over a hot iron, zinc or magnesium, hydrogen is liberated along with the formation of their respective oxides. Silicon has resemblance with metals in this property even though it is a non-metal. When a mixture of silicon and coke is heated in an electric furnace, silicon carbide, that is carborundum, is formed. Si plus C gives rise to SiC. This is an endothermic reaction since heat from the furnace is used for chemical reaction. Dissolution of ammonium chloride, common salt and sugar in water are endothermic, whereas the dissolution of sodium hydroxide, calcium oxide and sulfuric acid is exothermic. Combustion of fuel is exothermic reaction, but cooking of rice is endothermic reaction. Uses of silicon and its compounds. Silicon compounds. 1. Sand is used in preparation of glass. Silicon carbide is used in cutting and grinding tools. Sand is used in the construction of building to make concrete mix. Zircon, topaz are used to make ornamental objects. Quartz is used in modern clocks. Zeolite is used in removal of hardness of water and in chromatography. The largest application of silicon as a raw material is in the production of silicones, that is in organic polymers. Silicones are used in waterproofing treatments, molding compounds, insulating material for electric motors and other electrical appliances. Many of the plug points of heating circuits are made from silicones. Silicones are rubbery compounds of silicon, oxygen and hydrocarbons. Unlike common organic polymers, they do not catch fire and hence they find application in fireproof suits and insulating materials. Silica gel is used in chromatography. The element silicon is an intrinsic semiconductor. This can also be converted into more efficient extrinsic semiconductor through doping. These semiconductors find applications in transistor, diodes, etc., and also in IC, that is integrated circuits. Collect microchips, diodes, transistor from your nearest electronics shop and get information about their functioning. Think. Silicon is used widely even though germanium is a better semiconductor material. Why? Find the reason. Carbon is not a semiconductor in spite of its group being 14th group. Why? You might have observed the person sharpening knives and a pair of scissors on a rotating wheel. The wheel is made up of silicon carbide. Granite is polished by silicon carbide. If possible, collect a piece of broken silicon carbide and use it as a pencil sharpener. Silica crystals of different size embedded on paper is called emery paper or sandpaper. Collect emery paper of different crystal size and interact with a carpenter to realize the use of such paper. Due to the high thermal capacity and non-combustible property of sand, it is used as a sand bath during roasting. Sand bath is also used in the laboratory to carry out chemical reactions. Activity: dip emery paper or sandpaper in water, take out and shake it well. There will be no traces of water on the paper. Generally, compounds containing oxygen are water attracting. Though silica contains more oxygen, it is not water attracting. It's really wonderful. Though the reason is not confirmed, it may be due to the absence of porosity in the polymer of silicon. The structure is so compact that water cannot enter. You learn more about it in higher classes. Biological significance of and hazards. Diatoms, radiolaria, and siliceous sponges use biogenic silica as a structural material to construct their shells. Some plants, for example paddy, need silicon for their growth. Miners and stone breakers in asbestos factory, glass factory, cement factory sometimes suffer from a professional hazard, silicosis. This is because of the entry of silica into lungs. Silica particles are suspended in the air in the mining area, hence they enter lungs. Because of lungs exposure to pollution, the workers must be provided with a gas mask to protect their health. Thank you.